Let's start. Hello, everyone. So here we will implement two projects in Hackathon. The first is called DEX, and the other is called Lending and Borrow Protocol Platform. So this is the first project. We call it DEX. DEX is short for Decentralized Exchange. And our DEX will be based on AMM, which is short for Automated Market Maker. And if you Uniswap V2 use the AMM model to do the DEX project. So I post a link in our doc. If you open it, there is the documentation from Uniswap to describe what is AMM. So because we will implement a simple one. So what we are caring about only is the formula x times y equal to k. And k is a constant. So here we call it invariant. So and the xy represents the balance of the in the pair. So the formula represents, so whenever a trade happened, or we say a swap happened, the remaining balance of token A times the remaining balance of token B should its multiplication should be the constant. So K remains unchanged forever whenever the trade happens. And there is a graph here to describe there is an example here to talk about so how can be K can be unchanged. And so since it's unchanged, we need ignore the trading fee for each trade, because the trading fee will increase or decrease the value of the K. So we can ignore here. So we assume the trading fee is 0. And so we need achieve a DEX to swap A for B and swap B for A. And besides swapping, we also need add and remove the equality for the pair. So the liquidity provider can add liquidity, which means add token some amount of token A and some amount of token B into the pair, and and to make the pair has more liquidity, to make sure the users can swap from each other. And the liquidity providers will receive the shares of the pair, and our smart contract should make sure the price won't change when adding the liquidity. And with the share of the pair, the liquidity providers also can remove the liquidity based on the current shares he want to burn. So in our project, there are some requirements to implement the swap. We need so our DEX should swap a given amount of A for B and swap A for a given amount of B. For example, this is a Conflux testnet, and here is a simple front end. So if, like for example, I want to swap from CFX to USDT, if I so for example, if I want to swap 100 CFX, and so it will calculate, I can receive 36 USDT as a return. But if we want to get 100 USDT, it also, so we can also get the value we need, which is the amount of CFS we should pay. So that's two features. And as for and there is another term called slippage tolerance. We can ignore it to make it simpler. And also there is actually in Conflux there are 5% trading fee whenever the trade happens. We can also ignore the trading fee as well. And then we click, for example, I swap 10 CFS, I will get 3.9 USDT. So I can do the swap. And there is a pop-up window for the MetaMask and the Fluent wallet in my screen. You cannot see it. So if I click confirm the transaction, is submitted. So if we see the transaction details, if we see the token transferred, so because so we did so that's in practice. So there are 1, 2, 3 pairs involved, but actually we just implement one pair, right? So we swap from our wallet to pay the CFX, and we will get the USDT for 3.9. So that's the swap. If we see the liquidity, if we select the CFX and the USDT, if we choose if we want to add 10 CFX, it will calculate the corresponding amount of the USDT, because whenever adding the liquidity, the smart contract must make sure the price won't change. So it will calculate the amount of the other token. So that's the, and also if I change the amount of the USDT, it will calculate the amount of the CFX. So that's for the liquidity part. And after implementing the smart contract, we need to do the local testing. So if you're using, so it's recommended to use hardhat and travel as mentioned in the two sessions before. So that's for the first project. And the second project is lending and borrow protocol. It seems like a bank, so you can supply or we call it deposit the some tokens, and based on your collaterals, you can borrow the same amount with the same total price, total value of the other tokens. So so we should support multi coins, multi ERC20 token supply and borrowing. And we also notice there are some interest rate here is different. So because there is interest rate model, so if we check the AAVE V2 protocol, so there, so this web page showing the uh, uh, one of the interest rate model. So you can follow it, or you can create more simple one. So you can browse the website to see how it works. If we see some chart, so we will see there is, so at the beginning to some point, so so the point is called optimal rate. So before the optimal rate, there is a lower rate, and after the threshold, it will increase a lot. So you can follow a simple one to implement in your project. Let's go back. So that's for interest rate models. And so besides supply and borrow, we also need to withdraw and repay. So let's do some demo here. So for example, if I supply CFIs, oh no, let's supply the USDT, $1. First, we need to approve the contract to transfer back to the shares of the token. And after that, and supply the USDT, and just wait for the confirmation in pop-up window. Okay, done. We already deposit $1 USDT into the system, and based on the total value of the borrowed, so we see there is $2.87. So we can borrow, for example, borrow XCFX. Let's borrow some little and borrow it. So done. So I borrow the XCFX. So that's for borrow. If we want to repay it, So we can do the repay because I don't have enough to repay it. So I just cancel here. Also, we can we can withdraw it. If we see if we withdraw USDT, so see there are more interest I can receive. Approve again. And withdraw. Yeah, it's done. So I withdraw the USDT here, and also we need a price oracle to identify the actual price for each coin. But it's more complicated, so we can ignore it and hard code it in your local testing. So we can define by ourselves. Let's say CFX is $1 and the USDT is $2, whatever. So we can under testing we can simulate the system when under the price changes. So there is another term called health factor. So it will determine the amount the difference between the amount of the supply, the amount of the user, and its total borrowing value from the user. If the borrowing value is more than supply's amount, the health factor will be less than 1, right? Will be less than 1, and we will perform liquidation. So that's the bonus part, or we call it liquidation. So the liquidator will pay the 50% as the minimum, pay the user's debt. So for example, if here the balance is $5, we can pay is $2.5 as a maximum. And as return, we will return the value, some amount of the deposit amount from the user to the liquidator. So that's the liquidation. So we also have documents here. So if you want to do the bonus part, you can raise the documents. And that's for the second project. And after done the project, you need perform the local test and also simulate if the price changes and the health factor will falls below 1, and how liquidators should do the liquidation. Thank you.